Nanotechnology refers to the branch of science and engineering devoted to designing, producing, and using structures, devices, and systems by manipulating atoms and molecules at nanoscale, having one or more dimensions of the order of 100 nanometers or less. Nanotechnology can increase the surface area of a material. This allows more atoms to interact with other materials. An increased surface area is one of the chief reasons nanometer-scale materials can be stronger, more durable, and more conductive than their larger-scale counterparts. Nanotechnology commonly works on incorporate industrial, medicinal, and energy uses. These include more durable construction materials, therapeutic drug delivery, and higher-density hydrogen fuel cells that are environmentally friendly. Nanoelectronics. It refers to the use of nanotechnology in electronic components. These components are often only a few nanometers in size. However, the tinier electronic components become the harder they are to manufacture. Nanoelectronics covers a diverse set of devices and materials, with the common characteristics that they are so small that physical effects alter the material's properties on a nanoscale. Interatomic interactions and quantum mechanical properties play a significant role in the workings of these devices. At the nanoscale, new phenomena take precedence over those that hold sway in the macro world. Quantum effects such as tunneling and atomistic disorder dominate the characteristics of these nanoscale devices. Nanosensors. It refers to a sensing device with at least one of its dimensions being smaller than 100 nanometers, and for the purpose of collecting information of the nanoscale and transferring it into data for analysis. Nanosensors are not necessarily reduced in size to the nanoscale, but could be larger devices that make use of the unique properties of nanomaterials to detect and measure events of the nanoscales. For instance, in noble metals such as silver or gold, nanostructures of smaller size than the Broglie wavelength for electrons lead to an intense absorption of the visible near UV region that is absent in the spectrum of the bulk material. Nanosensors have been developed for the detection of gases, chemical and biochemical variables, as well as physical variables, and the detection of electromagnetic radiation. Nanotechnology can actually revolutionize a lot of electronic products, procedures, and applications. The areas that benefit from the continued development of nanotechnology when it comes to electronic products include nanotransistors, nanodiodes, OLED, plasma displays, quantum computers, and many more. Nanotechnology can also benefit the energy sector. The development of more effective energy-producing, energy-absorbing, and energy storage products in smaller and more efficient devices is possible with this technology. Such items like batteries, fuel cells, and solar cells can be built smaller but can be made to be more effective with this technology. Included in the list of disadvantages of this science and its development is the possible loss of jobs in the traditional farming and manufacturing industries. You will also find that the development of nanotechnology can also bring about the crash of certain markets due to the lowering of the value of oil and diamonds due to the possibility of developing alternative sources of energy that are more efficient and won't require the use of fossil fuels. This can also mean that since people can now develop products at a molecular level, diamonds will also lose its value since it can now be mass-produced. Wear personal protective equipment as needed. Avoid skin contact with nanoparticles or nanoparticle-containing solutions by using appropriate personal protective equipment.